were unable to make it to London. So here's the brief agenda. We're going to briefly go over some in situ OEM with Frank, some work on OEM for path consistency. We're then going to look at an alternative handling for dynamic chaining and service indirection. And then an update on the SFC in fog environments. So a more detailed agenda here with links to the drafts that are going to be shown today, or the talks. And then in terms of a working group progress summary, we've made quite a lot of progress since IETF 100. RFC 8300, which is the NSH encapsulation, was published as a standards track RFC. We worked on a new working group charter, so thanks to everybody that helped us to do that. So that rechartering has now happened and approved. Adrian's SFC convent draft as a proof of publication. So that's another piece of work, as well as the hierarchical SFC submitted to the IESG for publication as well. We've adopted a few new documents into the working group, primarily the Type 1 metadata documents, one for data center, one for broadband allocation, and also the Type 2, which is the TLV's document that we've talked about a lot of times. And then we started to make a little bit of progress on the OEM framework, updated, and we think it's close to a working group last call. So encourage people to go and look at that and provide comments. So with that, pull up the agenda slide.
So it's Frank first.
Yeah. So Frank, you're up.
Just bringing up the NSH NCAP draft first.
Yep, doing it.
Okay.
Getting there. And there it is.
This is actually a nice courtesy.
Sorry?
That monitor screen is a nice thing that they're doing these days. Okay, so quick update on what has changed from the 00 to the 01 version of the NSH NCAP draft for IOEM. Just next slide. So the main change that we've done is reflect the changes that happened in the data draft that's been progressed in IPPM. And what we found was, well, that it is very helpful from an encapsulation perspective for IOEM to have a structure that only requires the parent protocol to give us a single code point. That is sometimes a nicety. So in NSH, we might be able to ask for 3 code points, maybe, or even 4 code points for individual types that we're going to go carry in IOEM. In other cases, it is a mandatory thing. And so if we're encapsulating, for instance, into GRE, you need an either type, and the IEEE will only give us 1. So what we decided doing is we consolidated the data structures in the data draft so that you have a type field for all the various options that IOEM has, i.e. pre-allocated trace, incremental trace, proof of transit, and edge-to-edge options into individual type fields, so that from a parent protocol perspective, we only need a single type. And that is really what we changed and reflected in the draft here and the update, so that by now we only request a single code point for the next protocol in NSH. The other thing that we had, and we had that discussion back in Singapore, was should IOEM mean that the traffic needs to be kind of flagged with the OBIT? And looking at 8300, it's very clear on that. Customer traffic must not set the OBIT. And well, just by adding the IOM metadata to the customer traffic, we don't make the customer traffic suddenly something else than customer traffic, i.e. we cannot set the OBIT for that. That probably evolves into discussion whether we want to go and do something to go and help a SFF to eventually then still look at, is there anything else for me? Do we need another bid? Well, I think that's an open discussion, but
okay,
that's where we stand. So 2 more points. Can I just go through this and then we're doing that? Okay.
Stay on this slide.
Well, if you want to speak up now.
Okay, thank you. So you're saying that IOM is not interested in using OBIT.
No, that's not what I'm saying.
Active OEM is not interested in using OBIT either. So why do we need OBIT?
I'm not saying that I'm not interested in the OBIT. What I'm saying is that IOM does not change what the meaning of the OBIT is, i.e. if we're tagging IOM, if you're tagging traffic with IOM and it's customer traffic, the OBIT must not be set. If there is OEM traffic that would also be tagged with IOM, the OBIT would be set.
Frank,
the only
what
thing
is
is that we're
OEM
not altering the meaning of the OBIT here, and I think that's the only thing that I'm saying.
No, but what is OEM traffic? Let's use strict terminology. There is active OEM, there is hybrid OEM, which is in case IOM. What other OEM traffic you imply?
There's been a lengthy discussion on the OBIT back in, was it February 2017? That didn't really conclude. The confusing text is still in 8300, and I'm the wrong person to resolve that. Okay,
but you're saying if there is OEM traffic, what do you mean by OEM traffic?
OEM traffic per the 8300 draft, per the 8300 document is traffic that carries the OBIT. Why the OBIT is there? That's somebody else's decision.
No, that's what I'm asking. Why OBIT is there? Do we need OBIT?
I didn't put the OBIT in, Heinz. I'm the wrong person.
I don't think Frank's the right person to answer that.
That's a different question.
That's a different question. It's not really a fair question to Frank. So let's move on.
It's a question you can raise, but not relative to Frank's presentation.
I think it's a fair question to the working group, right? Why do we have the OBIT? I think you raised that question. It's been raised a year ago. It wasn't really resolved. Yeah. So the only thing that I'm saying is you're not using it. We're not changing the meaning of the OBIT.
Yeah.
If there is traffic with OBIT, it's going to be set. If there is traffic without OBIT, it's not going to be set. Next one. So the next slide just shows what the header format looks like with the new IOM type that's been defined in the data draft. That means we have an IOM type, header length, and then just next protocol. So it's a very clean shim by now. And we are only asking, different from what the original version was, we're only asking for a single code point. One thing that, I wanted to bring up again, we had that discussion, not really, but briefly. The draft still discusses that. There's 2 options that we can go do in NSH. One way is to encapsulate IOM metadata into MD type 2. Apparently, that's also what the early implementation in BPP is doing as open source. From an efficiency perspective, the many hardware people that we have supporting this draft and that are implementing the thing like the next header approach. Why? Because it doesn't really mean that you need to go through all the various TLVs that you might have in the NSH header, because there is no ordering, there is no priorities of individual metadata in there. So the next header approach is cleaner and simpler for hardware to progress, because we want a flat structure as much as possible. So that's a concern, but I wanted to go and raise that question again because, there can be devices that, are more easily going with metadata type 2. They can just skip that they might not be that easy on skipping something that is in the next header.
So,
So I wanted to go raise that question again and get kind of feedback from the room on that particular one.
Before
And
we
maybe
get
you wanna go
feedback, I
speak
wanna
up as an
clarify
individual contributor.
an important, somewhat subtle, but very important point about this. The difference between using next header and using TLV, there's two kinds of differences. One is the efficiency, which you've correctly pointed out, particularly for hardware, but even for software. It's more efficient to process IOAM if it's next header. I don't disagree with your assertion there. That matches my understanding. But there's a compatibility drawback. If you have existing deployed SFFs that need to do ECMP, and so are looking for the packet, they're not currently expecting to go skipping. They're going next header, packet, right. And more importantly, if you have existing service functions, they're expecting the next header to be the packet they work with. When they get next header, they have to look at it. There are two possible behaviors if they haven't been upgraded to do this. They might not have realized they can get multiple kinds, and they would do just completely the wrong thing, or they did properly understand they could get multiple kinds. They would not understand this, and they will promptly drop the packets on the floor, causing us to drop user packets. And having existing service functions drop user packets for a feature that we want to be able to incrementally deploy, yeah, for a greenfield financial that's going to install this everywhere and make sure everything does this because it matters. But even for the financials you described me, they only need to actually check some of this stuff at a couple of places. If you use next header, existing functions they need, as far as I can tell, will break. And I think that's very important. So I wanted to make clear the trade-off, and now I want to hear from the room.
Yeah, thank
Greg,
you.
then Kyle, and anybody else who wants to speak up.
Okay.
You have the time, please.
Yeah, I apologize to the note taker that I didn't present myself first time. Greg Mirsky, ZT. 2 points I want to make. We have individual draft multi-layer active OEM for SFC and networks that proposes for active OEM to use what we refer as a header, which can be set as a shim for NSH. I think that there is a reason to try to converge these two encapsulations for OEM so that there will be a single type of encapsulation that can be shared by active OEM and a hybrid OEM. At the same time, I point to the earlier work of overlay OEM design team that produced the OEM header work, and this will be presented later in NVO3 group and called for adoption. So again, I think that there is not much difference between active OEM and hybrid OEM, and it's worth effort to try to come up with a single encapsulation for OEM can be used by hybrid and active OEM and overlay networks in general.
Kyle Rose, Sandvine. So I mean, you could just have the next protocol being incompatible with the network be a control plane issue, right? If everything doesn't advertise it supports this particular next protocol, don't add the IOAM. Kind of sucks. But speaking of backwards compatibility, there's already an implementation of it in the metadata. Is it crazy to support both for networks which haven't been updated to support the next protocol? Send it in the metadata, incur the performance hit. Maybe some things will support it, maybe some things won't. But incrementally, we can move towards the more efficient next protocol over time. Maybe that's just too much work, but it's just an idea.
Yeah.
Well,
We always end up with this, it depends, right?
I mean, you can keep the
it's very
format the
difficult to
same.
make a choice, right? So, and that's where I said we started with MD type 2. Then the hardware people kicked in and say, well,
Yeah.
right, and this is why we're in this
kind of like
limbo
type 1 and
mode.
type
the
2.
other, look, I want to point out another thing. In terms of what I just heard from various people, since the formats don't seem to be the same, Now I'm imagining what happens if the packet has both OAM information as a next header and IOAM as a next header. We've suddenly lost the implementation advantage we wanted for using next header, because now, no, you've got to go skipping through next headers to see if there's a next header you want. And now you don't know when to stop skipping, because what are you going to special case TCP and UDP and know that, it actually gets messier. If we start having multiple next headers we define that are useful for us, we're going to undo the advantage you get from using next header.
Yeah.
I mean, am I missing something?
Again, Greg Mirsky, ZT. Joe, if I don't see the possible scenario when we have active OEM and hybrid OEM present in the same NSH.
Okay,
So,
either active OAM doesn't include hybrid, in which case I'm really confused, or I can have hybrid with proof of transit and something else, and all of a sudden, wait, I seem to have several next headers, and my head is exploding.
yeah, I think that we can avoid that by stipulating that hybrid OEM and active OEM should not be used in the same packet. So
Well,
we can limit this one extra header and have only one, either.
But Greg, if it happens to be that you're using your follow-up packets, then, well, the follow-up packet might just be, how do you classify the follow-up packet? Wouldn't it be an OEM packet?
But follow-up packet doesn't carry customer data. Follow-up packet is a hybrid OEM. That's it.
Although it doesn't carry customer data?
Yeah, of course. It doesn't have to. It carry information, but it doesn't carry customer data.
Okay.
That's why it's
well,
hybrid.
we can classify it accordingly.
Yeah, but
fair
again,
point.
we're introducing something that we not discussed. I didn't present the hybrid two-step here in this group, but so people don't have a context.
It's Horizon from Huawei. I'm just a little bit confused. NSH itself is not a transport protocol. And so while it's already been defined many ways to encapsulate IOM header into different transport protocols. So is this some duplication effort, or this IOM header is meant to be consumed and processed by the service functions?
Okay.
So I think we're touching on one of the use cases, and we can probably then progress to the next presentation.
Yeah,
which
we can
is,
present.
I think, touching on one of the use cases that
What I would
you're
like to
asking
do at
for.
this point is ask the minute taker to minute that we need to continue the discussion of next header versus TLV for IOAM and OAM, so that we don't reprise this. Thank you, Drew. I see you nodding. So it's in the minutes, so it will remind Jim and me that we need to make sure this discussion gets taken to the list and we drive clarity quickly. There's no point in dragging this one out, but we're going to have to just continue it on the list anyway. We're not going to resolve it in the room right now.
Yeah, but it's dragging for quite some time. So in order to at least get a sense where people are leaning, can we do something like a hum or something? Because
I can't form a clear enough question right this moment, sitting here as chair, to get a hum that I could interpret from the room. And we would have to confirm it on the list anyway.
yeah, we'll have to confirm it, but I'd love to get some indication where people are leaning.
Okay, what question would you like a hum on? I'm willing to take a hum.
From an encapsulation perspective, should we go with metadata type 2, option 1, or next header approach like we have it in the draft?
Okay, so this is a hum for preference for something like, when carrying information like OAM information, first hum will be, do we want to carry it as a TLV? It'll be a single MD2 type TLV. We're not talking about disassembling their OAM stuff. No. It would be a single blob just in the TLV. And then the alternative will be, would you like it carried as a next header? Would those who would like to see it carried as a TLV hum now, please? Okay. Would those who would like to see it carried as a next header hum now, please?
Okay, that doesn't really help. Thank you.
Thank you.
Yeah,
Next
well, it's
presentation.
like we're in limbo on that point for quite some time, and it doesn't really easily resolve, but because there's good arguments both ways. But thanks for that. What we don't want is two options.
Right.
No.
Doing it both ways seems like a recipe for trouble. Then everything has to implement two different mechanisms, and no. That's what we complain about ITUT doing. We're not going to do that.
So next thing was really, I think it's discussing one of the use cases for IOM and why we have it here. And we've looked at proof of transit for a couple of times. Let me just quickly recap the concept and, well, then discuss what really changed from an overall kind of scope perspective. Next slide. I think the question really that we do want to answer is, has my traffic gone through a sequence of service functions, and can I prove this? Not say tell my management, but prove it to my management, which is an ask from the financial community, for instance, where it came from. And one of the co-authors that we have, Steve Ewell, really pioneered that particular concept, because he says, well, there is a sequence of firewalls that traffic needs to make it through, and I need to verify and I'll prove that to my management in a cryptographically secure way. So next slide. Well, I think you get it. Traffic needs to go through A, B, C. That means it's compliant. If it bypasses B, it would be not compliant, and the responsible person would have trouble. So how do we do that from a concept perspective? Next slide. We take a secret, we split the secret into multiple portions, we give every single node a piece of the secret, and then as the packet progresses through the network, it picks up pieces of the secret, and later on we can either assemble the secret or we can't. And that way we can prove that the packet made it through the various hops that we want to go and verify or not. If you look at the draft, next slide, there's two options in there from a algorithm perspective. One uses Shamir secret sharing. It's very light on computational effort. So it boils down from a verifier perspective or from a hop-by-hop perspective to two additions, one multiplication, and one modular prime operation. There is another mechanism that is auto-preserving, but requires nested encryption. So the chip needs to go and support something like AES. We have the two options, one cheap but not auto-preserving, the other one more expensive but auto-preserving in the draft. How does it apply to SFC? I think the natural point where you do proof of transit is in the service functions itself. Those guys would, well, apply or update the proof of transit metadata that we have there in order to well, tell you that the particular packet visited the particular node. There is, so the service functions themselves would take care, would participate in POT. They would also receive the secrets, update the secrets and the likes from a controller. There is also another mode that you can go and think of, which is harder to implement, but possible, if you go to the next slide, where a service function forwarder or, well, somebody else in the chain would go and work on behalf of a service function that does not yet implement proof of transit. It's a little bit of an odd operation because, well, you got to go prove that it makes it through a service function. Why should somebody else do it on your behalf? Well, maybe you have a trusted entity, two sets where you trust the service function forwarder and the link between that and the SF, so that you can have somebody act on behalf of the SF. That is a bit of a difficult operation because it would mean that we would need to go and cache the traffic, well, we would need to cache the POT metadata for the time that the traffic traverses the SF and comes back, and then reapply it. It's been doable. We've done IOM caching, and again, there is open source code on that for another use case. where we hand the packet to the application. When it comes back, we reapply the metadata. Well, it's a use case, and we can go and document that as part of the draft. So next slide. So what has changed? Well, what has changed is the scope and the working group charter, so that, well, the working group by now is to go and also focus on privacy aspects and security aspects. And proof of transit is definitely one. And it's been even outlined, if you go to the next slide, in RC 8300, there's been a hint at proof of transit already. As part of the review comments that we received when 8300 was progressed to RFC, there was a notion of, well, you guys need to go and fix security. That is a portion of the puzzle. It's obviously not an entire and comprehensive solution. Jim, would you mind going to the next slide? Hello. We've done this thing now a couple of times, so everybody should be familiar with the concept. 8300 references POT. Security and privacy are part of the charter. So question is, can we adopt that? What we can do, we have these two slides. We can add a deployment section and say, well, this is how we would use it. And that would answer the question that was earlier raised on the floor. What do you do with this? How does it apply to SFC? But, well, personally, I think we're ready to go and progress that. So questions?
Good. Question, please.
And then we're going to do some more humming.
More humming.
Yes.
More humming after the question.
More humming with 50% each. That's awesome.
More humming coming up.
Kent Leong, should I start humming now? Actually, sorry, Frank, I haven't read this one. But since you're talking about the use cases, I think there's value here, right, to have this verification. I guess the thing I didn't see is that this works if it goes through all the services, basically, in the service chain, right? In either direction, you can verify. What happens for the traffic that is mid-path, basically, and goes back the other direction? The same, how can you verify, I guess, or differentiate the two different types of traffic? Is that one of the use cases that's covered here, or is there a way to distinguish the two cases? I'm not sure if you caught.
So I think right now the overall setup is unidirectional, right?
Okay.
So the return traffic would have its own set of secrets.
Yep.
And would be just considered an independent flow, right?
Yep.
So it's not really that you do this on a per session basis. You do that on a per flow and direction basis.
Yep. Okay, got it. So, but the key is that I think it depends on the type of services that's in the chain, right?
Mm-hmm.
So you're right in the sense that.
And by the way, just kicking in on that, we can use the same set of secrets both directions, right? So
Yes, exactly.
if you want that, you can absolutely do that and say, well,
Exactly.
neither whether it's left to right or right to left,
Right.
I can go and verify
Exactly.
the same
You can
way.
do however you want to see the secrets,
Yeah.
basically. Okay, I got that, but maybe we can take it offline. But I guess my point is that in the case where I guess it's the mid-path case, right? Traffic goes to the service chain, service function 2, and then we're processing it back. So now the packet goes the other direction, and service function 2 and 1. So now when you're verifying that direction, you only have 2 parts of the so-called secret. Then is it legitimate? Is it not legitimate? I mean, maybe something to just consider.
Well, did I say that it's not a headache if you do proxy behavior? It is a headache.
Yeah.
Yes, but well, people said, well, it's a use case. It's a bit of a corner case, but go and at least mention it, which is why we go and mention it.
Okay. Sorry.
But I agree, it's a mess, and you need to go and keep session state. You need to cache that information. And if you're running this whole thing at tens of gigabits, you better have a pretty large state table. Not nice.
Okay.
What do you do if the thing drops? If you need to go recover state? There's loads of questions with that.
Ken, I just want to clarify. So one of the use cases you're thinking about is where you've got a receive-only SF in the path, right? And you want to be able to verify that
Actually, I
receive-only.
wasn't thinking about that specific case. I was actually thinking more of the proxy case where, like a TCP proxy.
Okay,
So,
okay.
I mean, we're we're just trying to check, basically verify that. So, but like you said, there are different cases too, right? So
Yeah.
I was just wondering that when it transits out, right? Now, I know what we're doing is verifying that it went through, but the key is that sometimes we may not have. So I just want to make sure we're covering some of these
Okay.
cases, that's all.
Yeah.
Greg Mirsky, ZT. I apologize. What would be their intended status or track for this document?
Sorry, say again?
Intended track, would it be
Informational.
informational, experimental,
You're asking for an information.
or standard?
Yeah.
Okay. Because again, yesterday in IPPM working group, we had a discussion, and unfortunately, Yakov Stein is not here in the room, but he mentioned that he is intended to bring another solution, so it would be good if both will go in the same track. That's all.
That makes sense.
Aaliyah Atlas. I'm very happy to see this work coming back. We did read charter because security and privacy, and particularly this particular work, is critical to the functionality, deployment, and security, right, for the technology that this group is developing. As such, I hope that it's possible to have it mature enough and gain enough consensus that we do end up with a standards track solution. It doesn't have to be this one, Greg, but we need one. And also, to the previous hum and such, I mean, we need to get agreement and consensus towards one approach, right? We can't keep trying to do multiple things. For some of this stuff, it just increases the complexity of the solution, and there's already so many choices there that I think folks should really think, how about consensus and the meaning of it, and there's the technical objections of things we just can't live without. You know, if there's a serious problem with something, that's one thing. If it's not your favorite color of the week, that's an entirely different thing. Thank you.
Andy Malice. One thing I found interesting when I read the draft is there was no real mention of IOAM anywhere in the draft. So just to confirm, this could be implemented as type 2 metadata without IOAM, correct?
Yeah.
Yeah, sure. Okay,
You just
great.
need a home where you can carry 2 times 64 bits, typically. And if you want to go and refresh secrets more frequently, even 2 times 32 bits might be good.
Okay, cool. Thanks.
Okay, so
That's
There
the
was-
whole point where we go and where we decouple that, right? So it's like, I'm not requiring that this metadata is framed in a certain way. So, good point.
Samandra from F5. Just picking up on what Kent was saying, it just occurred to me, in many of the higher order services, there is no correlation between packets and services rendered. So that means I might get packet 1, 2, 3 and produce a completely different packet because of transformations, right? So if the verification process, let me say, a TCP 3-way handshake is a perfect example where a flow is kind of broken so that some packets can be aggregated and then new packets can be produced. But it's not breaking anything as far as the graph is concerned or services are entered. So I was just wondering, I don't have any objection or anything, I don't know, but we might have to look at that, how this verification process works. Because not all the packets are actually going to end up through the firewall. Firewall is a bad example in some ways because firewall is typically packet-based. You put a load balancer, you put any of the transformation engine, that assumption is completely broken.
Okay, I think I'm not fully following because the audio here is really sucky. But we can take that offline.
Yeah, I think that's better.
Just a thought. I mean, maybe we could have a second class of packets that are generated, and you indicate the point at which it was generated somehow in this trace, and for that you require that through transit from the generation point back to the exit from the chain.
Since we're all speculating here, so I think we can take it offline because I think there are different cases, right? When there's a proxy and one's a load balancer, proxy, different things. But I think certain cases you still go through the entire service chain, even though if the it's been proxy on both ends, right? So I think we can take it offline and maybe work out some more details.
Yeah, and I think in certain cases, and as I said, the audio here is not what you hear. But if you load balance, there is nothing stopping you if you have a sequence of service functions that are all implementing the same thing to go and share the secret across these service functions so that, well, if the ask is you go through a firewall that does this particular task, it can be any instance of that particular firewall, and all of them can share the very same secret and apply the very same action on a packet. So that's been accounted for, and that's one of the things that we even do.
So picking up on part of what our area director said, very helpful but now outgoing. Thank you, Aaliyah, for all your help before, and I hope we'll continue to see you as a participant in the future. But one of her points is we're going to want to move this forward. Now, assuming that the working group is interested in moving this forward, in order to fairly ask the working group for adoption, I think we need some sense of what the working group wants in terms of 1 versus 2 solution and which one. I do not want to get us into a situation where everybody agrees we need one answer, but we don't agree on which one. I've seen that, I've done that. Let's not make that mistake. So I want to ask a 3-branched question and not a 4-branched question right now. I want hums. We will be taking it to the list for discussion. People can put elaborations on whys and all that, which we need because the reasons matter more in many senses than the preference, but we're looking for a sense of preference. I'm going to ask, do we want the low computational cost mechanism that verifies transit but not order only? Do we want only the mechanism which at a somewhat higher cost, and I'm not going to get into a debate about how much, but it clearly is higher cost, verifies both transit and order only, or do we want both? Which would people prefer to see? And when you hum, you're welcome to not hum if you don't care, but if you hum loudly because it's a big room with bad acoustics. So those people who would like us to adopt a single solution, which is the low computational cost proof of which things you have transited, but not their order, please hum now. Okay? Those people who would like us to adopt the single solution that is more computationally expensive, but also captures order, please hum now. Noticeably less. And those who think we should adopt both solutions, please hum now.
That's
Okay.
sounds.
That's more than the second, and that's important because I have a preference, but the working group matters. We will take this to the list, but we know where we stand. Thank you.
All right. Thanks, guys.
Okay. Just let me know.
Good morning, everyone. I'm Ting Ao from ZTE Corporation. This presentation is about the service function chain path consistent OEM. This slide is about three times to present this draft. So the presentation is mainly focused on the update of the new version. Next, please. But in case this is your first time to view this draft, so I'd like to introduce the COM first. The COM is the path consistency check OM. So for every SFF in the SFC, once it received a COM request message, it will take 2 actions. One is to send back a COM reply with the service function information in this reply message. And another action is to send a COM request to its next SFF. So once correct all the COM reply message, the whole service function path can be confirmed. From last meeting, we received some comments of this draft. Thank you for all the comments. And the most important comments is how does SF with multiple SFs respond to COM request? So we update the draft in two parts. One is to update the format of service function information sub-TLV. In this sub-TLV, we add a service path identifier field. In this field, to indicate which service function path the COM is checking, and we reorganize the location of other fields. And in SF identifier fields, we confirm that the service function identifier can be lists. Another part, we add a new section about how to construct a service function information sub-TLV. And in this section, we mainly analyze the situation that multiple service functions attached to one SFF. There are two scenarios in this situation. One is multiple service functions as hopes of SFP. And that means these multiple service functions attached to one SF are several hopes of this SFP. So the service index of this F are different. Service function types of these service functions may be different. So all these service function information are included in one COM message, COM reply message. Every SF information should be listed as separate SF information sub-TLVs in COM reply message. Another scenario is a little more complex. These multiple service functions are for load balance. That means these multiple service functions are attached to one SFF for load balance. But only one service function will be transmitted by particular traffic. So these multiple service functions have the same service function type and the service index. And the service identifier of all these service functions will be listed in the service function identifier field in a single service function information sub-TLV. The number of these service functions can be calculated according to service function identifier type and the value of length field in the sub-TLV.
Okay, before you go on to the next slide, can you clarify something on this slide? Because there are two different ways load balancing can be done, at least, and there probably are more because we allow a fair bit of implementation flexibility. It may be that the service function forwarder is aware of the multiple instances and doing load balancing, or it may be that all he sees is something he thinks is a service function, but which is actually a load balancer talking to multiple instances using any number of instancing technologies. Who are you expecting is going to know how many things, and why do you think it may not even be a stable number? Why is that a number you want to return? I'm missing something here. Because it's consistent, no matter whether there's 1 or 10, it's still consistent with the path.
May, Greg Mirsky, ZT. Since that would be SFF responding, then only information that is visible to SFF would be returned. So if there is some other entity that proxies processing and it's not, and SFF is not aware of that processing.
It's
then,
not proxying, but I take
okay,
the
not
point.
the proxying, but again, doing something which SFF is not aware of.
Then I think you need to be very careful in the wording you put in on what the meaning of this multiplicity information is, because unless we're very careful, it will confuse people instead of helping them.
Okay, thank you.
If you're very clear, then okay, it's
Okay,
got a clear meaning, but
we appreciate any suggestions and comments to the document. Thank you.
Kent Leon. So my understanding after hearing this is that, Joey, you brought two cases, right? One is SFF load balancing to a bunch of SFFs, right? And I think this was trying to say, here are the SF instances, that it's responding to is what's said here. If it's a load balancer, it's an SF, happens to be a load balancer, that's load balancing other SFs. To me, from an SFF perspective, it's only just the SF, right? So it's always from SFF perspective, right? So I think that's how I just would interpret this particular case, right?
I'm just asking that we're going to need to be very clear about that.
Okay, good. I do have a question myself, though. Just to clarify this, I guess what I'm not quite clear, because it's been a while, is in this message, does it have the flow information as well? Because in the SFF load balancing case, right, if it's for a particular flow, maybe the OEM aspect, maybe I want to know which one you hashed it to, right, for example. So there might be two cases, right? One is that I just want to know, what are the SF instances that's behind you. The other one's that I have this flow. I'm trying to figure out where is it going, right? And you're doing the one who's doing the hashing, for example. So maybe you should return that SF instance with a subtype. I mean, I wasn't sure if you covered that case too.
This seems to relate closely to a question she has on the next slide.
Okay, sorry.
Yeah.
Okay, that's good.
Kyle LaRose, Sandvine, and maybe this is covered on the next slide, but are we actually carrying the identifier of every SF that could be reached on that hop?
You mean
So suppose that you're load balancing to 100 SF instances.
Well, and in particular, if you're doing load balancing across SFFs, which is also allowed, then you're only going to hit one of those SFFs, and you're not going to report all of the SFFs. And that's part of why I wonder about the load balancing.
I guess my concern is if we actually are carrying when the packet we return carries the ID of every SF that we could load balance to, it could get very large.
So you think we should consider the massive SF for load balance this scenario?
Okay, the idea is that, as pointed in a previous diagram, that each SFF responds to the query. So if we have 100 SFFs, then the responses will come not aggregated in a single response, but rather in 100 responses.
But
that's only assuming that all these SFFs are on SFP. Okay, so if you need to do something else to select particular SFF that performing the same SF type of SF function, then there needs to be done somewhere in NSH encapsulation, not in this consistency OEM packet.
Thanks, Greg. And my concern's actually not for the SFF to SFF case, but for the SFF load balancing to many SF case. The SFF could be load balancing to thousands of SFs. And if the ID is 4 bytes, 8 bytes, that's a lot of space to carry in a packet, unless we're fragmenting it or segmenting it somehow.
Okay, I hear you. For now, idea is that all SF will be listed in the same reply. So if that's something that concerns you, we'll definitely think about it, how to split it.
Would it be possible? I don't want to hypothesize, so I'll leave it.
Okay. Since the load balance scenario is a little complex, so we have some issues that are open to discuss in working group. One is SF identifier type. For load balance scenario, are the same, or are these service function have same service function identifier type? In current draft, we assume they are the same. So all the service function identifier list share the same service function identifier type. The second issue is the COM for SFP or RSP. In current draft, we think the COM should be for SFP. So we suggest to add all the belonging to the load balance group should be added into the service function identifier list. But it is still open to discuss.
Well, so the point is, if you want to measure the RSP, you have to have the flow identifying information in the packet, because the RSP is what path would this packet take. And if you want to identify that, you have to have the information that the SFFs need to make that decision. Now, sometimes in some implementations, SFPs and RSPs are always 1-1. Well, then the question isn't meaningful. But when they're not 1-1, it is specifically because some of the SFFs are paying attention to the flow identifying portions of the packet header, and you need to include that. We're not going to get, I would hope you're not going to get into those cases where reclassifiers look at metadata produced by other service functions and then choose to put you on a different SFP, and you want to cause this check to actually check that consistency case. I'm sorry, that makes my head explode at least. But if you have to decide what you want to accomplish, and if you want to check the RSP, you need the flow identifying information somehow.
Okay.
That's the definition of the RSP when it is different from the SFP.
Okay. Okay. Although it's the third time to present, we still welcome any comments and feedback, and we hope working group can consider the adoption of this draft.
I do think you guys need to go and clarify some of the issues that were raised before we can issue an adoption call.
Okay. Any questions? Okay, thank you.
Next one is dynamic service chaining. We're just pulling up your presentation.
Oh dear, this may take a while. Okay, here it goes. Yep.
Okay, thank you. Hello, everybody. I'm going to give a quick update.
Just putting it in full screen.
Okay, sorry.
There you go.
Okay, thank you. I'm going to just give a quick update on this draft, version 02, on behalf of my co-authors. Next slide, please. So just a recap, in this draft, we introduced a service function called SRR to handle what we call dynamic chaining. It decouples the service consumer and the service provider, and it basically creates a chain when the service is requested using name-based identification of service endpoints. And this function also uses, and I would say this is just one of the example where it uses HTTP as an application layer transport to realize the name-based identification. So it is what it describes an extension to the SFC framework, where URL-based addressing scheme is used, and SRR uses this name-based relationship to route to our specific instances of service function. Next slide, please. So in this slide, we just recap some of the discussions or questions that we received. One of the question was, is NSH encapsulation is utilized for forwarding between the service functions? So in this draft, also like whether SRR function can be embedded within SFF. Though it is not explicitly described in that way in the draft, but that is, of course, can be done. Also here, though NSH is not described as explicitly being used, because this draft mostly exposes the SRR function. But the SRR can be interpreted as an extension to the SFF, and in that case, the name-based hop information will act similar to the SRR. And the level of, in this draft, the level of abstraction for service function path has been raised to that of name-based chains rather than address-based one. And another question that was also is how is name-based hop is referenced in the data plane. So to elaborate on that, we can use this NSH, the path ID and the index as the lookup to find the next name in the path and then resolve the name to an IP endpoint. And this is also an alternative to DNS resolution, where the endpoint will have a given fully qualified domain name and the request is being forwarded over maybe an L2 network using path forwarding and not
what is,
routing.
excuse me, I understand L2 networks. We do allow Ethernet as a transport for NSH. That's L2 networks as I understand it. People use them. No argument. What is path forwarding? That's not a term I've heard in the IETF or IEEE. So you're referencing it as a way of doing something, but there's no reference for it.
Okay. So what the path forwarding is identifying end-to-end path and basically forward based on those end-to-end identification of the.
Okay, let's go on.
Okay. So in this update, we introduced another use case, which is basically the deployment of third-party cloud service providers, and also the deployment of micro data centers. Specifically, we see at the edge of the network, and that reiterates the need for flexible and dynamic chaining, and also some clarification on flexible and dynamic chaining has been also added there. So what is basically why do we need this? Some of the triggers can be load balancing and user or service mobility, or also optimization due to network conditions. And also this flexible and dynamic chaining can be viewed as a late binding compared to the static binding of service function chain. And third clarification is about this HTTP as a transport and how it helps in achieving flexible and late binding of service function chain. If we go to the next slide, please. So just to give a brief snapshot of the use case that we described here is mainly specific localized use cases, more at the edge of the network, which requires on-site data centers. And this is due to emergence of of real estate owners who are willing to deploy edge cloud resources. And basically, they are turning towards deployment of micro data centers at the edge. And these data centers are typically deployed at multiple internet point of presence. And what is happening due to this multiple point of presence deployment, now there's a trend of composition of service and at the edge, which is basically composed out of these multiple data centers. And this kind of implies that there will be data exchange and collaboration is expected among these micro data centers. If we go to the next slide, please. So continuing from the previous slide, as we see like the service composition over many micro data centers is basically maybe impacted and due to various conditions in the network. And some of the examples are like load variation in the networks and service endpoints being migrated, mobility of users. So in order to maintain the same level of service continuity for end users, SFC can support this, what we call also as flexible chaining. So chains, instead of defining statically at the time of service, ability to create chain at runtime is desirable. And also dynamic chaining as network condition changes, user location changes, this bindings needs to be redefined frequently. If we go to the next slide, please. So now the clarification that has been added as what is being meant by HTTP as a transport. So I think the first bullet is just it's a disclaimer saying that it's an example of a named service. And the solution can be applied for other name service also, even IP. And when we say HTTP as a transport, we just basically say that we are kind of abstracting and using HTTP as a common transport for name-based URI and end-to-end communications. And in the context of SFC and service function, what we have done is we have used or abstracted the HTTP request and response as service request. And we are basically trying to do this routing and indirections of this service request are nothing but are abstracted at the HTTP level. If we go to the next slide, please. So, and then how it helps in realizing this flexible and dynamic chaining. So this HTTP requests such as get, put, and post now are routed based on the URI associated with the request. And these URIs are basically the name of a resource or the invocation point. Now, if service functions could be identified using URI or this name, so the HTTP request to a service function would be routed or directed using name-based routing, and HTTP becomes an application layer transport service. And by updating this naming relationship, service requests can be redirected easily and as and when required. Next slide, please. So, okay, so I think that's the kind of the summary of the updates in this. And so the question is, does this kind of is in the scope of this working group, and is it something can be considered and also the next is this an ongoing work that we are involved, and we expect some more experiments on this H2020 Flame project. So that's the end of it. So maybe questions.
Sumandra, I did not read this draft, so sorry if I'm asking questions which is obviously explained, so bear with me. So some observation first. In general, I'm personally opposed to seeing yet another resolution point in network. I mean, it looked like you were saying SR can be replaced by DNS. If that can be done by DNS, I would prefer to be DNS. It's just yet another component in the network, never really works. Secondly, one of the examples said the URI based on URI figure out the path, I guess, right? So typically something called page routing, it has been done before. Page routing used to be used by Facebook. They still use it. They used to use third-party devices. Now they have written their own. And the other way to solve would be if each node is actually a classifier, then every node can make its own decision and point to the next graph, which is similar to programmatic graph. So I'm kind of confused exactly, are you just providing an alternative, or one should expect to use it because it has certain advantages over other approaches?
Yeah, so to answer to your question, it is definitely one of the way to implement flexible and dynamic chaining. And yeah, so with respect to the page-based routing, like I don't know, like I have to really go back and see what to say.
Okay. I mean, most of any L7 processor engine, that's their job typically, looking at URI and figuring out where to go. It's pretty common.
Kyle Rose, Sandvine. It wasn't clear to me whether we're talking about a control plane solution here or a data plane solution. So when you say we're trying to resolve hops with URIs, are you just saying that in the control plane, we say that this SF is reached at this URI, and then the SFF is responsible for mapping that URI to an actual layer 2 or layer 3 address and then forwarding an NSH packet to it? Or are we saying that we're encapsulating NSH within HTTP and then forwarding HTTP packets through web servers? Like I wasn't quite clear on that. Could you elaborate?
Yeah, so I would say, like as you mentioned about the control plane handling, like so we can encapsulate as I say the service request, which is in this case HTTP request is a service request, and we can encapsulate it within the NSH, And based on that naming, we decide the next, service endpoint.
Yeah, so my understanding, Carl, when I read it was, and I could be completely wrong, but my understanding was instead of you programming the SFF with path ID index equals next hop, you would program the SFF to say path ID index equals name, and then somehow you would resolve the name to a next hop through this HTTP mechanism.
Well,
That's how I understood
HTTP
it.
doesn't resolve names. HTTP relies on DNS resolving names.
I understand, but
There was a slide where you said, no, but we have an alternative name resolution. And then in your slide that says HTTP transport, you induced Kyle's question because you seem in that slide to describe the case where the underlying original packet is HTTP and the routing is based on the name, the URL in the HTTP. Well, we're not doing an application-specific protocol.
Yeah, no, but
So that's a different problem from the one we have here.
yeah, but the thing is that if you see, we have a disclaimer, HTTPs and examples, and we can apply it to any name-based approach.
Well, but if we're not going to be specific, we're not going to do things specific to applications which run on names. ICN or HTTP, that's our problem space is supporting user packets. We're not supporting user applications for the problem space NSH is working on. So let's try to keep ourselves focused on problem. The question of what are the entries in an SFF point to is a question we can discuss.
Yeah.
I have trouble getting my head around why I'd want a name there, but that's a different question from what applications. It's got to be generic to the application.
Well, let me maybe I can give an example. Like, a simple use of an SFF would be I say that at path 5, hop 3, the packet goes to IP 10.0.0.1, right? And then, are you saying that in your example, it's path 5, hop 2, packet goes to some URI?
So yeah, if I can say that, so in the SFF, it will be like, say, basically, as we said, right? If you form the chain, it will be based on those names. So say, for example, example.com goes to example1.com, example2.com. So now what the SFF, or if we think SFF is an extension of SRR, so that will be resolved within that. What is example1.com means there? So that will be resolved in the SRR, what example1.com means, right. And based on that, it will be.
So I think part of my confusion is coming from the introduction of almost an entirely new architecture on top of SFC. Like, I've seen many terms that are similar to but slightly different from the terms in SFC, and it's making it very hard for me to understand the document. So if we could just discuss a document in terms of SFC, it would make this working group understand it much more easily. So again, instead of talking about an SRR, what is the SFF doing? If you can just describe how a packet flows through the SFF in terms of SFC functionality, it would be like, it would be great. The packet arrives, you look up in the forwarding table, the SPI and the SI, and what does that result in? How does the SFF actually map that packet to the next hop? Does it do a DNS lookup, and that gives you an IP address, and you write the IP header, and you do an ARP, and then you do an ARP lookup, and you find the next hop MAC address, and you send it there? Is that how it works? Or do you?
Yeah, and I think
yeah.
Just to follow on from that, I think the other thing, at least from my perspective, was exactly as Carl said, but it would be nice also to really be clear on the problem that's trying to be solved here. In other words, the way that the SFF currently works, there's a lot of background in why all of this edge computing stuff's coming along, and it's not obvious to me as to why what's being defined currently in the SFC working group is not sufficient for that new environment. In other words, the problem that you need to really be clear on what the problem is and why what we've currently done won't work in that environment, and then describe how your solution actually works in the data.
And I think, and kind of where I was going with this is there was a slide that said the path was an address, and I never thought of the path or like a specific SFP referring to addresses. It could easily refer to names, and this is really just a property of your control plane and how you tell your SFF about the service functions. and how that SFF is required to map those service functions to actual physical devices.
I tend to prefer not to do DNS lookups on as I get packets coming into my line rate forwarders, but you're
Well, no,
allowed.
but I mean, like, if the control planes talk, I mean, you can optimize these things, right? Like you know, update them once a second or something and have a do anyway. But so I think if we're talking about defining a control plane that is, you know, a standard, you know, maybe there's a Yang model that describes how to use URIs to represent service functions, and then we talk about how to render those down into SFFs. Maybe that's useful, but I don't like this idea of, it doesn't seem like we're doing something that's incompatible with SFC or even really an extension of SFC. It just seems like it's a specific implementation of SFC. Like, it really feels like that to me. And I'm struggling to understand how it is something uniquely distinct from SFC such that it requires all this new terminology. Anyway, it's...
Okay.
There's a question at the back there.
Question in the back and then the other on the front, Mike.
Yeah, another question, probably clarification. Doug Trusson in the digital, one of the co-authors, as a matter of fact. In the discussion with Jim, actually, Jim, you brought up something around integration to the SFF that we didn't want to write in the draft originally. So that's probably the reason that caused the confusion. We outsourced a lot of these functionalities in a dedicated SRR, which creates quite a bit of the confusion part. I think the discussion goes in the right direction to be a little bit more integrative with the ideas of SFC, describe what we're doing as either an extension, or if it just boils down to a particular implementation of SFF, then that's probably it. Right. The background to that as an explanation, it's not an excuse, it's an explanation, is that a realization as an external function came out of the work where the project work that Debashish is referencing in the last bullet item, where this work comes from. So the first realization we had done is to completely outsource the behavior into this SRR, and that's the one we are describing in the draft. But I think the discussion initiated through your email and at the meeting here really points us towards thinking much more integrative in the, you know, how could it work with the SFF as it is at the moment, and what's the required extension, if any, or is it just implementation specific? Do we just have a very good SFF? That could well be that could well be true, but that's just it. The SFF that we are creating is just particularly good compared to others, right? So that's kind of, it does help to actually scope it down. And so it wasn't a question, it was just a comment, and that's appreciated.
Thanks.
Kent, actually, I think that kind of hit a lot of my points too. You know, I think this has a bunch of things in the draft. Sorry, I haven't read it too. You know, it has the problem statement. It has the whole SRR architecture and whole explanation, which is good for background, right? Because actually, after you present it, I kind of get what you're trying to get at, right? So the whole dynamic, flexible, I would say, server's abstraction is kind of what you're searching for, you know, in line. So I get the idea, but I think how we achieve it, I agree with the earlier point. Actually, there's, you know, you can kind of abstract out what you guys are even talking about, and, you know, and we can pretty much, in my head, I think we can pretty much implement the way it is today, but you have the general abstraction of SRR to do dynamic resolution, basically, right? Which is what you're really trying to do, right? Each hop, how do I dynamically resolve it? And the key question I have here is that, and there's a fundamental assumption here that your SFF has to be stable to be able to ensure this works properly. Because, you know, once you resolve it, you have to pin basically what you resolve to and maintain that service path, which really ends up being the RSP at the end of the day. Actually, you resolve everything along the way, right? So I'm not sure if you capture that, because I know that you said that this SR becomes SFF, you know, blah, blah, blah. But the reality is that you would need to be stable to achieve what you want to achieve, from my understanding, based on your whole resolution aspect.
Okay.
Okay, we'll move on to the last
Thank you.
presentation. Fog, discovery in the fog.
Okay, I'm Carlos Bernardos. I'm presenting this on behalf of my
co-authors. So this presentation is mostly kind of problem statement 1. Basically, we are exploring how to discover service functions in a fog environment. So I will basically describe what I mean by fog environment, the motivation for that kind of discovery, and then some potential ideas of how to do this or how to perform that discovery. So next slide, please. So the motivation is basically that we are now seeing that virtualization is becoming or is getting closer to the final user. So we are not just restricted to the data center model, but we have resources that are very close to the user or even are at the user devices. So those resources may be mobile, may belong to different stakeholders. So this is what we mean as the fog or as the edge or as the smart edge, this kind of terminology. So basically it's resources that are more volatile, more heterogeneous, and are closer to the final user. So the idea is that in this environment, the user can benefit from, or a device may benefit from using those resources or functions running on those resources that are close to the final user. But it's a much dynamic environment than the classical data center-oriented environment. So in this environment, we need that discovery of what is available. And not only the discovery of what is available, but also the characteristics of those things that are available, because it's not the same thing discovering a function that is meant to be like more static than being something that is going to be volatile, is going to be gone in a few minutes or in a few hours. So this is basically the idea of the motivation from this.
Can I ask you to clarify who you intend the discovery to be used by? Because in the deployments we talk about for SFC, the end terminal simply addresses his packet to the end service he wants to reach. He doesn't worry about these. It is all about transparent insertion of services. So can you clarify, because the way the bullets are structured, it looks like the mobile terminal is discovering the services, and I had trouble putting that in an SFC context.
The idea here is basically, it's a very good point, is in our case, or in the scenarios that we are addressing, is the terminal being an active participant. So we are trying to explore extending SFC to the terminal. So we will see this in the next slide.
You probably should in the draft make really clear that you're talking about a somewhat different use case where the end user is invoking the SFP.
Yep.
That's rather than a classifier. Because if you read the SFC architecture, we're very clear there's a classifier who drives this. And you're talking about a different case. Okay, let's continue.
Yeah, please, next slide. So basically this picture tried to show the scenario. So we have this continuum from the data center to the final end user device. And the fog is this continuum where we have resources even at the run or at the end user device, and DNS functions in general can be run on any of these devices. And in the next slide, please, basically we go into your point. So a mobile terminal in this environment can benefit. So is the mobile terminal really playing that role of discovering the service functions to enhance the existing applications and the performance of the applications? So some examples is the terminal getting some function for doing video transcoding or to do privacy enhancements or to do local breakout, these kind of things by the end terminal discovering those functions and doing the whole service function chain. So, and this is useful for many different reasons. That's what is covered in the second part of the slide. That is, this may allow the device to increase the battery life for the mobile terminal. So we are really looking into a mobile terminal-centric scenario to reduce the communication latency from the mobile device by using local breakout servers or gateways that are available close to the final end user device. To benefit from functions that require or benefit from information that is local at the access. So there may be some functions that require information from the radio access part to perform the functionality they intend to do. So benefit also from context information that is only available at the very local access. So these are examples of opportunities brought by using these functions close to the end user device. Next slide, please. So what we are trying to look is into mechanisms that allow to discover these service functions. So basically the characteristics of the function, if it's SFC aware or not, the type,
the IP address of those service functions, but not only to discover the functions, as I said at the beginning, but also to discover the characteristics associated to the resources hosting those functions. So, for example, the mobility, if the functions are battery powered or not, if the functions are meant to be more volatile or not, the price, if there is any associated to using that function, the migration capabilities of those functions, if we can move those functions to a different place if the user is moving, all these kind of things that allow the mobile terminal to decide whether to use or not an available service function. Next slide, please. Next one. Okay. So these figures basically represent a couple of use case examples. So basically, in the first one at the top of the slide, we have a terminal that is attaching to the network. And in the network, there are service functions available, and the terminal basically requires some mechanisms to discover those service functions. So there's a very simple diagram, basically based on a request or based on periodic advertisements from the network to the devices that are connected. But in our scenarios, it's not only based on having a fix or an available infrastructure where the device connects, but also between mobiles. So we may have like a vehicular scenario or other types of scenarios in which different devices interconnect, and those devices have service functions available that can be used by other devices that are nearby. So that's the diagram that we have at the bottom of the figure. Next slide, please. So as I mentioned, this is basically more like a problem statement kind of slide or presentation. So we want to first understand if the working group is interested in looking into this kind of use cases. As you very well mentioned at the beginning, is a different use case from what has been addressed in SFC so far. And if so, we will continue working on describing actual solutions. Here we are just describing the overall picture. And well, that's it. If you have any comment, please, that would be very appreciated.
Hi, Kyle Rose, Sandvine. This is pretty cool. And so I just had a couple of thoughts. So I think Joel or Jim, I can't remember who exactly it was, touched on this earlier. So is the terminal actually acting as a classifier here? So inserting the NSH encapsulation?
Yeah.
Have you considered maybe moving that into the access point and just having the negotiation of which service functions you want applied communicated somehow with the control plane? Or do you think that it would be too challenging for the classifier to actually identify the particular chain you want to go on? That's
a very good point. We are now open. I mean, we are exploring the solution space. That's a potential solution. It also depends on the dynamicity, whether this access point is going to be always the same or we are changing. So that's depends also on the particular use case, but it's a very good point. That's something that we could explore.
Some other thoughts. I think I really just had one other thought. Have you thought about the multiple uplink case? Maybe using PVDs or something to discover the information. I know it gives you information about your uplink, but not necessarily about yourself to the wider network, but that might be something to consider. I know a lot of people have been thinking about what happens when you have multiple ways of accessing the network. What we've been learning in those groups might be worth considering here too.
Yeah, that's also a very good point. Related to this, it's not exactly the same thing, but something we are also exploring is, but it's maybe not for SFC, but in general for this environment, is to actually, when you have multiple points of attachment where you can connect to, deciding on which you connect based on the availability of the functions that point of attachment brings. So this is something that we are considering as well. Maybe it's not for SFC working group, but it's also in the scope of that.
And that's why I was thinking maybe PVDs would be a good way to get this information, but then if it's really dynamic, it might not be appropriate. So,
okay, thank you very much. Very good feedback.
Thank you.
Okay. If anybody has not signed the blue sheet, please come up and sign. Otherwise, thank you for your time. Adrian, what is it?
Can I just say to the working group that there's this MPLS SFC draft that you may have noticed. I'm here if you want to throw vegetables at me. Stuart is going to be presenting it in MPLS tomorrow to try to level set what we're trying to do. The message, and I have presented it to the working group before.
Yeah.
My message to the working group is we are not trying to piss on NSH, okay? NSH exists, good, go for it, work on it hard. We are trying to totally reuse this working group's SFC architecture. We're not trying to rewrite any of that. And we're looking at a niche deployment.
Thank you, Adrian.
But still
Fair
throw
enough.
fruit.
Actually, I need to.